Okay, we're going to do a little bit of live teaching this morning. Let's hide that. I'm going to give you guys a few more minutes to get logged in. Okay, so lucky you for who's in here. You don't have to watch the video, you get to actually watch me teach for a little bit. Sorry, if you don't have me, you don't get to see your teaching today, but maybe another day. I'm just waiting for a couple more minutes. I got some people joining in on our Zoom call, okay? I'm gonna record this and post it on Google Classroom. So if you miss something, you'll be able to see it later today. You don't do anything. You just gotta watch me teach you. All right, so let's go ahead and get started. We are going to talk about the distance formula today, this week. And basically, what we're going to be doing is we're going to be finding like perimeter of objects, using the distance formula. And the distance formula you'll see later on down the road in geometry too. Let's first talk about like, what is the distance formula? And here it is. This is the distance formula. This is exactly what you would see on the air formula sheet for distance. So I know last year you didn't take the air test, right? No, you didn't take the air test last year. I don't know what's going to happen this year, if you're going to take it or not, but this is what you will see on the air test. Okay, they do give you some formula, so this is what you're going to see. So that D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. What do you think the x1, x2, y1, y2 represent in the formula? What do you think? Say that again. Yeah, they're points, right? On the coordinate plane. So x1, y1, that's a coordinate. x2, y2, that's a coordinate. Good job. So what does distance represent? How could you describe distance in your own words? What do you think? What does distance represent? Yeah, general. Good, perfect. How far you are from one place to another, okay? How is distance different than slope? Does anybody know? Yes. Perfect, wonderful, good job. Distance is how far you are, and slope is how steep that line is. So remember, rise over run, that's slope. But distance is how far you are from one point to another. Good job. Okay, so I got this example here. And it says, what is the distance between -9, -6, and -2, -2, okay? So we've got that distance formula. Let's see if I can, ooh. Okay, our distance formula. X2 minus X1 squared plus Y2 minus Y1 squared. Okay, and that's all underneath. So what do you think X1, X2 are, Y2, Y1 are? Well, up here, right? Go ahead. What were you going to say? Yeah, X1 is -9. Perfect. -6. Just there, the coordinates are X and then Y. So yeah. X1, Y1. And then -2 is X2, Y2. Okay, so what do you think we should do next? Oh, you can't see, I'm sorry. What do you think we should do? Probably just what? Or, yeah, plug them into the formula, right? And subtract. So I'm going to go ahead and do that. So I'm going to plug in -2 minus a -9 squared. This is all underneath the square root. Plus Y2 is a -2. Y1 is a -6. Okay, what happens to these minus negatives? Yeah, good, they add. Okay, same goes here. So what is -2 plus 9? Good. So we have 7 squared plus, what's -2 plus 6? Good, 4 squared. Okay, what's 7 squared? What's 7 times 7? Good. 49. And then 4 squared. Good, 16. Good, 65. Why do you think they didn't take the square root of it? Because why? It is the distance between those 2 points, but why do you think?
The final answer.
What's the answer?
65.
Yeah, you're right. But why do you think they didn't, Bobby, why do you think they didn't actually take the square root? Does anybody know? Why didn't they take the square root?
But it gave a bigger number.
Say that again.
It would have gave a bigger number.
Really?
Can you type that up? I can't hear you.
You logged in?
I've been logged in.
I don't know.
I've been logged in since 8 o'clock. I've been logged in for 20 minutes.
Where's the chat?
Okay.
I'm doing some live teaching.
Okay.
So just watch me.
Miss M,
Yeah.
somebody said because 65 isn't a square number.
Perfect. Thank you, Miss Stanley. Yes. 65 isn't a square number. Yes.
That
yes.
was Stephen B.
It's
that
not
said
a
that.
Perfect square. Okay. Does anybody know a perfect square? No. A perfect square. Have you ever heard that term before? Right. It's not a decimal. So if you take the square root of it, like the square root of 9 is what? 3. Yeah, that's a perfect square. 9 is a perfect square, right? 65 is not a perfect square. So when you take the square root of 65, you're going to get some sort of decimal. That's why they just left it like that. Okay? Okay, let's keep on going.
Is there a pear deck for us to follow along with?
All right.
Miss
See
M,
if
did
you
you
can
hear
try
that?
to find the distance between these 2 points on your own. Okay, take a couple minutes. We'll go over it, but just see if you can try to find the distance of these 2 points on your own.
Miss Johns,
Yes.
is there a pear deck for the kids to follow along? Some kids are asking in the chat.
No, I did not do it because
Okay.
I had some technical difficulties today. Thank you for asking. Sorry. All right. Anybody help me out, get started just a little bit? What could I plug in? What do I do?
I can tell you.
6? Okay, so if I label this is my X1, this is my Y1, here's my X2, here is my Y2. Okay, so 6 minus what? Good, -2 plus -13 minus -2. Good. What happens here again? Minus a -2, what happens? Yeah, it becomes positive, right? So what's 6 plus 2? Good. So we have 8 squared plus, same thing happens here, right? It becomes plus -13 plus 2. What's that?
Negative.
Good, -11. Was anybody able to figure out what goes underneath? What's 8 squared plus -11 squared?
64.
Good, 64 plus 121. Okay, what is 64 plus 121? Say that again. 185. Is that a perfect square? Do we know? Is there a way to check it out to see if it's a perfect square? What can we
Square root.
use? Yeah, a calculator. Yeah, absolutely. So I'm gonna see if I can exit out of here and get a calculator. I'm gonna pull up Desmos real quick. Okay, so I'm just gonna type in, there's my square root of 185. What do we see here? We see a 13.6. Is it a perfect square? No, it's not. So we may keep it like this. I need to go back a slide. We may keep it like this. Or if they ask for decimals, or maybe round to the nearest 10th, we would write 13.6. Okay, does anybody have any questions with that? Okay, let's keep on going. Let's find the distance using the graph. Okay, so notice here, what do we have to find? Yeah, we got to find the distance, but do we know like where these points are?
It would be for X and Y, and then X1 or X2 and XY.
Yeah, so we would find, we'd have to find the coordinates of X1 and X2, right? And Y1 and Y2. So what is that? What is this point here? If I count 1, 2, 3, 4, 5, 6, 7, 8. 8, 2. And this one over here is -4. And then up 1, 2, 3, 4, 5, 6, 7, 8, right? Okay. Now we're able to actually find the distance using those 2 points, correct? All right, so let's go ahead and do that. Does it matter which one's X1, Y1, X2, Y2? Do you think it matters? Like, can I do like,
So
can this be X1 or can this be X1? Do you think it really
Yeah.
matters? No, it
No.
doesn't. So I'm just gonna do, we'll do 8 minus -4. What would be my next one?
2 plus 8.
2 minus what? Good, 8. Okay. So 8 minus -4 is what? 12, good. And then 2 minus 8, -6, right? Okay. 12 squared, good, 144. 6 squared,
-36.
good, 36. What is it? 180, good. Is that a perfect square? No, it's not, good. Okay, there's another way we can find the distance using a graph without using the distance formula, okay? Anybody have a suggestion or idea or thought?
I'm sorry, what'd you say?
Say that again, Bobby.
I said, what did you say?
I can't hear you. Say that one more time.
What did you say?
Oh, I'm asking if there's another way that we can find the distance using a graph. So I got this on a graph here.
Rise over run.
Yeah, that's what you said over here. It's kind of like slope. It's not necessarily slope, but if I were to draw something like this, does anybody see anything? What type of triangle is that? A right triangle. Does anybody know a specific like theorem. Yeah, Pythagorean theorem. So if that's A, that's B. This distance right here, that hypotenuse is C. So we can use the Pythagorean theorem to also find that distance right there. Does that make sense? So we would have to make a right triangle like that. Okay. Well, let's see here. So, and all you have to do would be to count. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that distance is 12. And this distance is 1, 2, 3, 4, 5, 6.
But wouldn't you square them? Because a squared plus b squared equals c squared.
I'm sorry, I can't hear you. Do you mind typing in the chat? I have Miss James here. She can help you if you have a question. Okay, so 6 squared plus 12 squared. Oh, isn't that what we have over here? Yeah, we do. That should be 180. But remember what the Pythagorean theorem is. It's a squared plus b squared equals c squared. So it's not going to be 180. What am I going to have to do to that 180?
Square it.
Square root it, right? I'm going to have to take the square root it. That's how you undo that square. And that would be our answer there. Does anybody have any questions? Can someone punch that in the calculator for me and tell me what's the decimal for that? What's the square root of 180? Yeah. 13.4. That's rounded to the nearest tenth or one decimal place. 13.4. All right. See if maybe you can kind of try this on your own using whatever method. So if you want to use the distance formula, use the distance formula. If you want to use the Pythagorean theorem, use the Pythagorean theorem. Did anybody use the distance formula? No? Yeah. Did you use Pythagorean theorem? Yeah. I'm gonna show you Pythagorean theorem again. So a squared plus b squared equals c squared. Okay. So remember, c is that like hypotenuse. So
3.
what's the distance here for a? How far is that? 3. Good. So we'll have 3 squared. This distance here is a little bit longer. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. What? Did you get it? Oh, okay. What's c squared? Or what's 3 squared, sorry? 9, good. What's 14 squared? Yeah? 196? Equals c squared. So 9 plus 196? Good, 205. Is that a perfect square? Is that a perfect square? No, it's not. Let's see if, can anybody take the square root of it? What do we get? Square root of 205.
14.3.
114?
No, 14.3.
14.3. There we go. Good. Thank you. Let's see, what else do we got? Ooh, what's the length of this line?
Oh my goodness.
What is the length of this line? They don't give you coordinates, do they? If they don't give you coordinates, what do you got to do? What do you got to use? If they don't give you coordinates, what's the method that I just taught you? Using what special? Yeah, the Pythagorean theorem, good. So if they don't give you coordinates, use that Pythagorean theorem. So this is 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're going to do 5 squared plus 12 squared. And that'll get us our c squared.
25 plus 196.
25 plus 144. What's 25 plus 144? 169. Is that a perfect square? Sure is. What is that perfect square? What's the square root of 169? Good, 13, which that's what our answer is right here. Okay, I think that is it. Does anybody have any questions with Pythagorean theorem or the distance formula? Okay, I'm gonna post these slides and the video on Google Classroom today. So if you need to like rewatch it or reference it, you're more than welcome to head back and watch it and reference it at your own time. But there are assignments this week due on Wednesday. So, all right, thanks for joining in. If you're a Zoom caller, we appreciate you. Okay.